Good morning. Welcome to the fourth lecture on the subject Economics, Management and Entrepreneurship. If you recall, in the last three lectures, we were talking about economics, in particular managerial economics, and in which we started discussing about demand and supply of products and services, and how in the market an equilibrium condition can exist, and how equilibrium demand and equilibrium supply can be estimated. In the last lecture, we talked about demand elasticity, how demand changes with different factors, and today we are going to discuss about demand forecasting. Demand forecasting is very important, particularly for an entrepreneur. To start with, let me clarify that demand is not same as sales. Sales of an enterprise is the amount that is delivered to the customers and the amount of money realized from the customers. That is the sales, whereas demand is the potential demand for the product in the market. Therefore, demand is always greater than or in the limit equal to sales. Estimating demand is what is forecasting. Forecasting is basically estimating the future value of the potential demand of a product or a service that an enterprise offers. Anything that is to be estimated for the future is difficult. In particular, if there are large number of factors that influence the value of the potential demand. Therefore, it is not surprising that there are a very large number of methods that have been forwarded in the literature and being practiced by the enterprises throughout the world in making estimates of demand. Now, before I proceed further, let me say that demand is always difficult to estimate, because it is very uncertain and because there are large number of factors, as I said, but whatever may be the accuracy of the demand, a decision has to be taken, because it will be useful in many ways for many purposes. So, in today's lecture, we shall basically study different types of methods that are used popularly in academics and in practice, and also say how they are useful in decision making. So, in this lecture, we shall first of all focus on uses of forecasts, methods of forecasting, and in particular we shall discuss and highlight certain aspects of qualitative, time series and econometric methods. First, need for demand forecasting or uses of demand forecasting. First thing, for an entrepreneur, particularly the one who is starting an enterprise newly, capacity planning is very important, and for that a long term projection of the demand is important, and based on that the capacity of the company can be planned. Once capacity is planned, the actual production plan will depend on the short term forecast. Also, how much to inventory to hold, so that no sale is lost, no demand is lost. Forecast of demand is quite important. Once the production is planned, we would like to also purchase the input materials and services to actually produce those goods. So, that will also depend on the forecast made. How many sales force to actually deploy, so that we can sell the amount that we produce, is actually planning distribution network. To which market and by which means, by deploying how many salespersons we will be able to sell our products, will also depend on the demand forecast that is made right in the beginning. Management of working capital, to deploy resources, the input materials, the machines, the power that is required, all that requires money, and that is working capital. Once we know, or we can make an estimate of the demand, we can similarly make an estimate of the need for working capital to be able to sustain in the business. And finally, if we know that our demand is so much, accordingly we can also decide on the prices that we shall charge for our product. Now, these are only a few areas which we mention as the uses of forecasting. Basically, a forecast is an information for decision making, and decision making for capacity planning, for production planning, for inventory building, for distribution, etc. All these decision making requires an important input of forecasting. Therefore, forecast is important. Now, there are different methods of demand forecasting. We would like to categorize them in three groups: qualitative analysis and quantitative analysis. Quantitative analysis can be further subdivided as time series analysis and econometric models. Now, there can be different ways in which the forecasts can be divided or grouped. This is one way in which I have grouped the demand forecasting methods. First, let us talk about qualitative forecasting. In qualitative forecasting, normally we do not deal with numbers. Quantitative forecasting uses numbers. Qualitative forecasting on the other hand does not rely so much on, or does not use numbers. We divide qualitative forecasting methods in two groups: expert opinion survey and consumer survey. Expert opinion survey can be further subdivided into three individual items: personal insights, panel consensus, and DELPHI method. And the consumer survey method can be divided as sample survey method and end use method. Now, let us study these two, each one of these in more detail. To start with, we talk about the personal insight. Basically, it depends on an individual, an expert who is extremely wise, highly experienced. He has lot of ideas, and the person can make a judicious estimate of the demand for the product in the market. So, naturally, it is very difficult to get hold of such a wise, knowledgeable, insightful and experienced person to be able to make a good estimate of demand. He can be totally incorrect or he can be totally correct. It is very difficult to say to what extent the expert's estimate is going to be accurate. Therefore, the normal practice is to get a panel of experts, a group of experts, and try to have an interaction among the panel experts, so that a consensus among them emerges, and that consensus would possibly would be more accurate than an individual expert's opinion. Now, there are different ways by which the panel of experts ideas can be obtained and an interaction among them can be conducted. One is based on interview. Now, if it is a personal interview, then naturally no interaction is possible. Personal interview could be face to face interview or it could be even a telephonic interview. Now, in such cases, because there are more than one expert, it is expected that different factors that one might overlook will surface, and the effect of those factors on the estimates of the demand can actually be understood, estimated and projected. Therefore, it is expected that there is a greater degree of confidence that we can have on the estimate made by this panel of experts. Now, sometimes the panels are brought to a meeting where their opinion is collected, each expert's opinion is collected. Now, the panel therefore face each other and interact among themselves face to face. In such a case, also a consensus can come, but it can lead to a lot of difficulty, particularly if there is a senior person who publicly makes his or her opinion, then it is difficult for him or her to retrace it or to change it. Similarly, if a powerful personality holding a senior position makes a statement, it is not impossible that the juniors will keep quiet, although they do not really or quite agree with the statements or opinion made by the senior member. Like this, there are quite a lot of difficulties if meetings of experts take place, and through a meeting the estimates are made. Now, because of these difficulties, there are various other methods and in particular a method that has emerged in the last few years, 2-3 decades, is the DELPHI technique. DELPHI technique is basically a series of questionnaire surveys among panel members. Not one questionnaire survey, but a series of questionnaire surveys among the selected panel experts, and the responses obtained in every round from the experts are summarized, and the summary response is sent back to each individual member of the panel, so that he or she can actually change his or her opinion on the basis of the group opinion that is available with him or her in the form of the summary response of the previous round. Normally, in the second round or in the third round, we have quantitative responses, and in that case what normally DELPHI technique does is to find out the median of the responses and the interquartile range. So, median, like mean, is a measure of the central tendency, and interquartile range is like standard deviation. So, when a summary response is fed back to the members of the panel, the group response is made available to each one of them in the form of the median value and the interquartile range value of the group responses. And finally, the reduction in the interquartile range as the number of rounds progresses is a measure of the extent to which consensus among the members of the panel takes place. This in short is the DELPHI technique. It has the advantage that a senior member of a panel cannot influence or bias the opinion of a junior member, yet they can have interaction. They have a chance to change their opinion because of the multiple rounds of questionnaire survey. Anonymity is maintained, nobody knows who the other members are. Therefore, the estimates are unlikely to be biased. And now we take the case of the sample survey method. This is a very popular method used by enterprises to make forecast of demand. Here what is done is the number of potential customers is first estimated. Let the number be capital N. Then randomly a sample of such potential customers is selected, and let the size of this sample be small n, and then through a method of interview or a questionnaire survey, their individual requirements is obtained through the survey method by meeting each one of them, by talking to each one of them, either through telephonic interview or by sending questionnaire survey or making face to face contacts. Then if there are small n number of such customers with whom contacts could be made and their individual requirements could be obtained, then the average requirement is x1 plus x2 etcetera plus xn divided by n. This is the average individual requirement, that multiplied by the total number of estimated potential customers capital N is taken as the market demand. This is a very simple method, but this is a very powerful method because it directly asks the customers, the potential customers, to talk about their individual requirements. Now, we go to the end use method. Here we include particularly the celebrated input output model of Leontief. It is useful in making consumption demand projection of various industries at a national level, and this is very useful for planning at the national level. So, at the enterprise level it is not so much used, but at the national level the input output model is quite useful. We will just have 2 or 3 slides on what this input output model is. Let us first of all define Xi as the output of industry I, Xic as the consumption demand of industry I, Xim as the amount of goods imported by industry I, Xie as the amount of exports made by industry I, Xif as the final consumption demand of industry I, and Aij is the fraction of output of industry J consumed by industry I. Now, from the above, particularly these 4 things, Xif, the final consumption demand of industry I, is equal to its own consumption plus imports minus exports. This is the relationship therefore. Xif is equal to Xic plus Xim minus Xie. Let us understand, here we are trying to say the consumption demand of industry 1 is its own consumption, final consumption plus the amount of goods produced in different industries, a fraction of it consumes. For example, steel industry consumes some coal, some iron ore and things of that type. So, each one of them is an industry. X2 probably is a coal industry, iron ore this industry. So, a fraction of the industry of different industries is consumed by steel industry, and similarly coal industry consumes something from other industries. So, these are input output coefficients. A's are input output coefficients. So, we have, if there are n number of industries, we have n number of such equations, and x1 contains A1 on x1, and therefore, if we take it this side, it becomes 1 minus A11 into x1 is equal to this. Therefore, it can be shown that the final demand vector, final consumption demand vector Xf is I minus A inverse into x. X is this vector. Xf is the vector of final consumption demand plus exports, net of imports of various goods. I is the identity matrix containing ones in its diagonal, 0 elsewhere. A is the matrix of input output coefficients A11, A12, A1n, AN1, AN2, ANN. Now, this model was used in many countries including India for a very large number of years. Now, we talk about time series analysis. Time series analysis, we can broadly group them under three headings: trend analysis, regression method and leading indicator method. Let us look at them one by one. What we mean by a time series basically? When we consider a time series, basically we talk about only one variable, let us say x1 at time 1, x2 at time 2, x3 at time 3, etc. So, this is called a discrete time series, where at time t equal to 1, the value of x is x1, at time t equal to 2, the value of x is x2, and so on and so forth. This is called a discrete time series. Normally, it is written as x t equals 1 to now each time series can have different components. It will have a component on average, a trend, a seasonality, cyclicity and random fluctuations. We can write it in this manner, we can show it in this manner in a graphical form. Suppose that this is time t and this is x t. X versus t can take different shapes. Suppose that it is exactly constant, it is same at all times t, then we will say that this is the average value or a constant value, but this hardly happens. X is something like the demand variable whose forecast we would like to make. And it is unlikely that it is constant, at least we shall expect that there will be certain random fluctuations around this constant value. So, we might expect values such as this So, which means that there is an average value and there is a random fluctuation or an error term. So, this is what I am trying to say, that this is a case where there is an average, but this is a case where there is an average plus a noise. Let us take another case. Now, here is a case of x t varying with t, and we can say that it has an average and the average has a trend and there is a random fluctuation around it. So, this is average plus there is a trend, a linear trend in this case, plus error, random fluctuation or an error around it. So, there are three components of a time series present in x t. Take up another case where t x t shows now, if you look at this, it has an average has a trend and it is associated with a seasonality, a perfect seasonality. So, this has average plus trend plus seasonality. Seasonal products like fans, air conditioners will show average, trend and seasonality, but it is unlikely that there is no random error present. So, we might in fact come across cases where it is something like this. Now, this blue color variation says that it has all the components of average, trend, seasonality and also it has an error term. So, this is the fourth component of a time series that we have shown here. Another component of the time series is cyclicity. We have heard of business cycles where the demand shows not regular fluctuations, irregular fluctuations of different periodicity. So, here we see that there is a rise in the value and there is a fall here and a fall here and a fall here, a rise here. Now, this periodicity may not be same. Unlike the case of seasonality, where the periodicity is exactly equal, in this case it may not be equal. Another cycle could be of this nature. So, here you will see they differ, the values are different. The troughs are also different. So, this is the case of cycles. We call business cycle, 2 to 5 year, and there are different other cycles such as Kuznets cycle, Kondratiev cycle, Kuznets cycle periodicity is between 5 to 10 years. Kondratiev cycles are called long waves between 50 to 100 years. Basically, we are trying to say that if we are concentrating on a particular variable whose value in the future we would like to estimate, then we can make an analysis of the past values of that particular variable x. That x in our case is demand, and we can make an analysis of the time series data of the value of x. It has got 5 components: average, trend, seasonality, cyclicity and random fluctuation, as I have just told you. And autocorrelation, since we are dealing with only one variable x t, we can find how x t is related to its Laggett variable x t minus 1, how x t minus 1 is related with x t minus 2, etc. This is called autocorrelation, and with the help of autocorrelation studies, we can find out whether trend is present, seasonality is present. Therefore, autocorrelation holds a very important place in the time series analysis, but unfortunately, we do not have time to discuss and go into the details, but I will give you some idea about what I am trying to say here. Trend analysis is the first thing that I am showing. Here I am trying to say that this diagram, this is the average value and that has a trend, but the actual data has random fluctuations. So, suppose we are assuming a linear trend, then the equation of x t is nothing but a plus b t, plus there is a random fluctuation, but at least we are able to find out an estimate of the average value at any time t. So, given the past data, we can basically make a projection of the past data by assuming a linear fit to the past data. The linear fit is given by the equation x t equal to a plus b t. So, given a time t, we can find out the value of x t, and normally we use the least square estimates, meaning that we actually take the data, this error at different time points we find out, and we find out the intercept value of this a and b, the trend we estimate on the basis of a criterion of minimizing the squared of the error. Now, there can be different types of trend analysis. Suppose we assume exponential trend, that means we take x t as equal to a multiplication e to the power b t. We can make a log transformation. We can say ln x t equals ln a plus b t. Now, this then becomes linear in the parameter, just as it is in the case of linear trend. We can even assume a double log or a log-log relationship between x and t in this manner. Suppose that x is equal to a multiplication t to the power b, taking ln, we get ln x is equal to ln a plus b of ln t. This once again is linear in parameter. So, by making suitable transformations, we can convert a nonlinear relationship such as this or this into a linear relationship in parameter, and thereby we can use the simple regression techniques to find out the values of a and b, and therefore, to make a relationship, to find a relationship between x t and t, which is what can be done. Now, when we not only use time, not just use time as the independent variable, but we take different other variables as the independent or explanatory variables, such as x 1, x 2 and x n. Suppose that we are assuming that there are different other variables such as x 1, x 2 and x n that determine the value of y, and then we call this a multiple regression equation. This is that error term that about which I was talking, and we would like to find out the estimates of the values of the parameters beta 0, b 0, b 1, b 2 and b n to be able to find out y. Once again, we try to minimize the least square error, minimize the squared error, and xi is the ith independent variable. We are not discussing here the methods of regression analysis, but we are just trying to tell you the methods that are normally used. Next, we just expose to you certain advanced topics in time series analysis. We call them autoregressive moving average methods, autoregressive AR standing for autoregressive, MA standing for moving average method. We are talking about time series analysis. So, let us say that y is the time series data y, and this is one period lagged value y t minus 1, 2 period lagged value y t minus 2, k period lagged value is y t minus k, and this is the error term. Now, if y t is related to its past value in this manner, then it is called AR order k, of the order k, autoregressive model of order k. Moving average model of order L, on the other hand, is related to E t in this manner: A plus B 1 E t minus 1, B 2 E t minus 2, B k E t minus L plus E t is called the moving average model of order L. Sometimes both are joined to give ARMA model of order k and L, k for autoregressive part of ARMA model, L for the moving average part of the ARMA model. So, y t is equal to, taking from here, B 1 y t minus 1, B 2 y t minus 2, etcetera, B k y t minus k plus A plus E t plus the rest of it, which is B 1 E t minus 1, etcetera. Now, this looks quite complicated. In actual practice, one can just have k is equal to 1 and L is equal to 1, in which case this becomes much simpler. Now, sometimes, say for example, here what we have done, we are showing here that the difference of two individual time series data, adjacent time series data, is stationary. So, y t minus 1 is E t. So, we take we difference the value and work with the value, the differenced value. This is called REMA, I standing for integrated, autoregressive integrated moving average methods. So, when we difference to make non-stationary data stationary. Now, here let us say this is same as an AR model, an average value, error term, and this is the related y related with y t minus 1. This is a case of MA 1. You can see this is a constant, this is the error term, and this is the moving average term. Here both AR and MA are present without differencing. So, this is a case of ARMA 1 which is this part is autoregressive, this part is moving average, and this is constant, and this is error term. Next, we talk about the leading indicator method. Basically, leading indicator method is like saying that find out if x is the, if y is the demand which you would like to estimate for a product, find out some other indicator for y. For example, if cars sell more in the market, then wheels will change more. Therefore, if you are interested to project the demand of wheels, you see how y is changing. If y is rising, it is expected that x will rise, but not exactly in the same phase with a phase difference. That is why we say the demand of y is a plus b x t minus k. So, this is also called a barometer because x is acting like a barometer for y. We now come to econometrics method. Basically, econometrics methods can be single regression equation such as the one that we have already discussed, or it can be simultaneous equations such as the two equations that I have written. You will see here that C t, the consumption expenditure at period t, is a function of y t, the income, but y t in turn is also related to C t. Therefore, it contains two equations and there is a circular causality between y and C, as you will see here. Now, econometrics itself is a very important and difficult topic to discuss. This is just to expose to you the fact that forecast models can be quite complex. Now, here we are trying to say that there are different forecasting methods and that normally we use to find out which forecasting method is the best, we use different criteria. To use the different criteria, we first of all find out the forecast error E I. This is called forecast error. Suppose that the past value or the value available with us for the variable x at time I is x I, and using the method we can find out, we can estimate or we say that the forecast value of x at time I is f I, then the difference between the two is taken as the forecast error, and the criteria that we can use can be many. I have just listed 3 of them. This is mean squared error, which is all the squares over n terms, average value dividing by n, mean squared error. It can be mean absolute error, absolute values are this and the average is this. It can also be mean absolute percentage error. Percentage error is basically x I minus f I by x I into 100. Absolute value is taken here and averaged. So, one can use any one of these 3. There are many other methods also and one can use them to find out which forecasting method should be used. Finally, we come to the case of when so many forecasting methods are available, which forecasting method to use. Now, this is a difficult task. There are once again many ways by which the different forecasts can be used to have the best possible forecast. What is suggested here is that one can make forecasts using different forecasting methods. Let us say that there are k such forecasting methods and each one of them yields different forecasts for the same time period. Let us say the forecasts are f1, f2, f3 etcetera up to fk. What is suggested is that you give certain weightages W1, W2, etc., Wk, indicating the importance and the confidence you are associating or attaching to each individual forecast. Then sum the weighted average, that is W1 into F1 plus W2 into F2, there is a mistake here, it should be F2 and plus Wk Fk, all that should be added. These weights should sum up to 1. If that happens, this forecast is taken as the best forecast. Now, friends, as you must have seen, I have glossed over the topic of forecasting. It is quite involving. It can be highly mathematical, but the fact remains that one never knows unless the actual time in the future happens. One does not know whether your demand is accurate or correct. In the absence of such future information, the only way, or there are two ways I would say. One, to use the expert knowledge, or two, to use the past data. If you use expert knowledge, one should use a panel of experts, find out what they have to say about the future demand and have a consensus. If on the other hand you are using past data, there are a large number of mathematical methods, regression methods, econometric methods, time series methods. They can always give some estimates, but finally you can always give them certain weights and take an weighted average value of the forecast of the demand. Thank you very much.